Hey, welcome! Today we're going to peel back the curtain on an invisible shield. It's a shield you've probably used 1,000 times without even realizing it, and it protects you from some of the most powerful forces in nature. So let's jump right in.
You've probably wondered about this, right? You're in a car, basically a metal box, and a crazy lightning storm kicks off. Everyone tells you you're perfectly safe, but why? Or you step into an elevator and poof, your phone call is gone. Well, believe it or not, these two things are connected by the exact same, really powerful principle.
So, to get to the bottom of this mystery, we've got to look at the invisible architecture of our universe. We need to talk about something called electric fields. They are the absolute key that unlocks this whole puzzle. So what in the world is an electric field? Well, every single electric charge, like an electron, creates this invisible field of force all around itself. You can kind of think of it like a planet's gravitational pull, but for electricity. This field dictates exactly how any other charge that wanders by will get pushed or pulled.
And this force, it's not chaotic or random at all. Nope. It follows this beautiful, predictable rule that just pops up all over physics. From gravity to light, it's called the inverse square law.
The law itself is pretty simple. As you move away from a charge, the field gets weaker. But here's the catch. It weakens with the square of the distance. So, you double your distance, the force is now 4 times weaker. You triple the distance, it's 9 times weaker. It drops off really fast. But here's the coolest part. This 1/r² thing, it isn't just some random math equation. It's a direct result of us living in a 3-dimensional universe. Just imagine that force spreading out in all directions, like the surface of an expanding balloon. The surface area of that balloon grows with the square of its radius, so the force at any one point has to get weaker by that same amount. It's just geometry.
Okay, so we've got our first big clue. These invisible fields are everywhere, and the forces they create follow a very specific geometric rule. This idea is the foundation for everything that's coming next.
Now let's add another layer. Energy. Electric potential energy. It's a lot like gravity. Think about the effort it takes to push a giant boulder up a hill. The higher you push it, the more potential energy it has, right? It's the same idea here. The work you do to move a charge against an electric field gets stored up as energy in that charge.
So, here's the key takeaway. A charge's physical location inside an electric field gives it a specific amount of stored up energy. This idea that energy is tied to position is absolutely vital for solving our mystery.
All right, we have our tools now. We've got electric fields, we've got the forces they create, and we've got the energy stored inside them. We are now totally equipped to go back to that car on the lightning storm and that elevator that keeps dropping your calls.
The answer, the secret behind why the metal box works its magic, is all about the amazing properties of materials we call conductors. And it's all about their incredible ability to just cancel out electric fields entirely.
So what is so special about a conductor, like the metal in a car or an elevator? Well, inside any conductor, the outer electrons aren't stuck to their atoms. Instead, they form this kind of sea of free-floating electrons that can zip around almost instantly in response to any electric force from the outside.
Okay, this is where the magic happens. Let's walk through it. Step 1, an outside field, say from a big lightning cloud, hits the car. Step 2, that sea of electrons inside the metal immediately rushes toward the positive side of that field. This causes a big pileup of negative charge on one side of the car, which leaves the other side positive. And now for the really crucial part. Step 3. This separation of charges creates a brand new electric field inside the metal, but it points in the exact opposite direction. And finally, step 4. The new internal field is perfectly equal and opposite to the external one. They completely cancel each other out. The net resulting side? Nothing. Zero.
This whole phenomenon has a name, of course. It's called electrostatic shielding. When you wrap a space in a conductor, you create this little bubble where the net electric field is always zero. The conductor is literally working in real time to neutralize any external field, creating a pocket of perfect electrical silence inside.
Now, to really appreciate how special this is, let's compare conductors to insulators, things like plastic or wood. In an insulator, the electrons are locked onto their atoms. There's no free-flowing sea. So when an external field hits them, the electrons can only stretch a little bit. This stretching, it's called polarization, and it does reduce the field a bit, but it can't cancel it out entirely. That complete cancellation, that's a trick only conductors can pull off.
You know, there's actually a measurement for how well an insulator can polarize, and it's called permittivity. A material with high permittivity can stretch a whole lot, and that lets it store more energy from the electric field.
In fact, this is the entire principle behind how capacitors work. They use these materials specifically to store up charge. And look, this isn't just some abstract theory. This is technology you use every single day. The steel body of your car is an electrostatic shield against lightning. The metal braid inside a coaxial cable shields your internet signal from interference. That metal mesh on your microwave door? That's a conductor trapping the microwaves inside. And yep, the metal box of an elevator is what's blocking the radio waves your cell phone needs to work.
So we've pretty much solved our mystery using the rules of classical physics. But what if I told you that's just scratching the surface? Modern physics suggests that the very nature of these forces might point to a much deeper and, honestly, a much stranger quantum reality.
Take a look at this quote from a research paper. It proposes a pretty wild idea. The fundamental forces of nature originate from the imbalance of the quantum fluctuation energy. What that's basically suggesting is that what we think of as a force might be something else entirely. Here's the core of the idea. Empty space isn't really empty. At the quantum level, it's fizzing and bubbling with something called quantum energy. This theory proposes that an electric charge doesn't actually create a field from nothing. Instead, it just disrupts this energy that's already there. The force that we feel is just the universe trying to settle back down, trying to find its lowest energy state again.
And that leaves us with one last mind-bending thought. What if electrostatic shielding, lightning, cell signals, all the electric forces that run our world aren't fundamental actions at all, but are just the large-scale echoes of a chaotic, roiling quantum sea that underpins all of reality?
Thank you for joining this explainer.